Warning: this video contains clips and excerpts of a humorous nature not normally found in math class. These are intended to fight the adolescent condition known as short attention span, found heavily in the modern teen, especially when in school. The only thing you should attempt at home is the math. The rest, you just laugh at. Hi, welcome back to AT Math. Today, we're going to do 5-5 direct variation, why it's more fun than the maze game. And we're back. Alright, so direct variation basically just means y, which is the rise, divided by the run, which is x. Now you remember before how we had y2 minus y1 over x2 minus x1? Well, here's a neat trick. If something goes through 0, 0, all you have to do is take any point and just take y divided by x, and it'll work all the same. The k in this case is like the slope, but k means it's conditional to going through 0, 0. So let's take a look here. Must go through 0, 0. We just talked that. Pick a point, any point. So here the y value is 4 and the x value is 2. So all you have to do is take 4 divided by 2. Slope is 2. Just that easy. Now why do we do that? Otherwise I have to pick 2 points and take y2 minus y1 over x2 minus x1. But if it goes through 0, 0, all we have to do is take y over x. Any point will do. So again, in this case, we don't even need a graph. We could just check each column of the table. So here I can just take 4 divided by 1, 8 divided by 2, 12 divided by 3, 4, 4, 4, all the way across. So the slope is 4. So the slope is 4 each time, so it is a linear function and a direct variation. It's a linear function because it's a straight line. It's a direct variation because it goes through 0, 0. Just like that. Because if it don't go through 0, 0, then it ain't a direct variation, and you can't just take y divided by x. Let me show you what this means with this wacky thing here. There we go. Get you on the right path there. Because if it don't go through 0, 0, then it would not be a direct variation. Well, that's very nice. A little animation problem there, but nothing we can't fix. Take this example. Let's take 6 divided by 1, 10 divided by 2, 14 divided by 3. Go ahead and see if all three are the same. And I'll bet you knew that they weren't. Because 6 divided by 1 is 6, 10 divided by 2 is 5, and 14 divided by 3 is a mess. So these are why aren't these the same? Because it didn't go through 0, 0. I mean, they all have, let's see, 4 over 1. 4 over 1. Slope's 4, up 4 over 1, up 4 over 1. How'd I do that? I just picked 2 of them. Didn't matter which 2. I just took 10 minus 6, which is 4, and 2 minus 1, which is 1. So my slope's 4, but because it doesn't go through 0, 0, it's not a direct variation, so this ain't going to work. As you can see, it is not the same because it didn't go through 0, 0. Let's go ahead and take a short commercial. And we're back. Here's a hint. If you see this, y equals 5x, and no plus or minus after, that's a direct variation. If there's a plus or minus after, it ain't a direct variation. So it does not matter what the slope is, but the fact that there's no intercept means it goes through 0, 0, which makes it a direct variation. So here's proof with the table. If I would take these here, 5, 1, 10, 2, 15, 3, notice how they're all, the k is the same. But this will not be a direct variation. This one here because of plus 5. Plus 5 throws it all off. Not a direct variation because there's a y-intercept, meaning it's not going to go through 0, 0. But let's just graph and see. Notice we have this. Notice it doesn't go through 0, 0. Now I'm going to plug these tables in, and notice now 10 divided by 1, 15 divided by 2, 20 divided by 3. The k is all screwed up because it's not direct variation. To sum up, direct variation, just slope and y. Not direct variation, any intercept at all. K, and when you have direct variation, you just take y divided by x. Understand that also y equals k over x. Now why is that? Because if you have this here, to get y by itself, instead of divide by x, you times by x. Times x to one side, times x to the other. So you could have y equals kx as well, as you can see here. So what's the difference between them? Y equals kx and y equals mx plus b. Well, basically the k and m are both slopes. The difference is k means it has to go through 0, 0, and y equals mx plus b means there is an intercept. Therefore, we have to compare two separate points to find their slope. So now this one here, 2x plus y equals 10. Instead of plus 2x, let's minus 2x. Minus 2x from one side, minus 2x to the other. And you get y equals negative 2x plus 10. But because there's an intercept here, it's fine. It's a linear equation, but it's not a direct variation. Take this one. I'll go ahead and, let's see, get y by itself. First, instead of minus 3x, I'm going to add 3x to both sides. Then instead of times 5, divide by 5, divide by 5. Really, it should be divide by 5, but 0 divided by anything is still 0. So y equals 3/5 x. Even though this is a mess, meaning a fraction, there's no intercept after, so it's still a direct variation. Commercial time. All right. Lastly, we're almost done. The value of y varies directly with x, and y equals 6 when x equals 12. Find y when x equals 27. Simply put, when they say y varies directly with x, that means direct variation. That means going through 0, 0. So, k equals y over x? No k. Y is 6, x is 12. So you get 6 12ths, or 1/2. And then they want to know when x is 27. Well, y equals kx. Now half, x is 27. You can just take half times 27. Remember, y equals mx plus b. We don't use y equals mx plus b because there's no y-intercept, so we don't need it. Y equals kx is fine. Could I use y equals mx plus b? Yeah, if I had 2 points. But say you only have 1 point and you still want to find the slope. If you go through 0, 0, you're in luck. And that's why we do this method. Because if you only have 1 point but it goes through 0, 0, you're still in good shape. Anyway, half times 27 is 13.5. Or a second way you might find it easier, if I know it's 6 over 12 anyway, which is y over x, 6 over 12, and this one here said x was 27, I just do a little crisscross applesauce. So times and divide, and we're still good at 13.5. Or you could reduce this to 1/2 equals y over 27, crisscross applesauce, still going to be 13.5. So no matter how you want to play it, that's fine with me. You try. Last try. The value of y varies directly with x, and y equals 5 when x equals 3. Find y when x equals 27. Well, you can do it a couple different ways. You could just take y over x, which is 5 over 3, plug 27 in, 27 times 5 divided by 3 makes 45, or, looky here, 5 over 3 equals y over 27, crisscross applesauce, magic, it's still 45. Okay, we're all done. Thanks again. Enjoy the rest of your night, and I'll talk to you later. Bye.
The white rhino and the African elephant are two of the largest animals on Earth. Their massive bulk adds power to their charge, and they can ram that point home with a 4-foot horn or 7-foot tusk. They live side by side, but when aggression strikes, the results are often fatal. First up, with the gray trunks, the elephant. Weighing 8 tons and standing 13 feet tall, male elephants make mean sparring partners as they fight for dominance or to defend their young. Bouts are fought with tusk and trunk. Packed with more than 100,000 muscles, the trunk is both tool and weapon. This young wildebeest gets a warning swipe. Yet elephants can kill a full-grown lion with a single blow. 7 feet long, normally used to dig water holes and strip trees of bark, these tusks can deliver a deadly goring. Elephants can pry open the trunk of a car or stomp it flat like a tin can. Great intelligence sets the great giant apart from his rival, the rhino. But will brains and brawn prove a winning combination? Of the several rhino species, the male white rhino is perhaps the most dangerous. Weighing 2.5 tons and standing 6 feet tall, he'll fight for mates, for territory, or just for the sake of it. Bad eyesight means he treats any movement as a threat. In the rhino world, a big horn is a status symbol. The bigger the horn, the easier to find mates. The rhino sharpens his horn on rocks and trees. With its solid base and sharp end, the horn is lethal in attack. At 4 feet, it's almost twice as long as a human arm. Agile and angry, can the rhino counter the elephant's size and strength? It's time for our contenders to go head-to-head. On the plains of Africa, a solitary bull elephant searches for food. Nearby, an ill-tempered white rhino has left its mud hole, also seeking good grazing. The scene is set for an encounter between two of nature's most feared heavyweights. So what do our two beasts bring to the fight? Horn versus tusks. Head versus head. And speed versus weight. When these Goliaths engage, it will be a true battle of giants. Why did the elephant in our scenario win? The elephant answered the rhino's challenge with a show of strength, but the rhino called his bluff. Too bad for him. The much smarter elephant anticipated his charge and thrust. In this heavyweight bout, size does matter. The rhino couldn't reach the elephant's throat, even with a 4-foot horn. The rhino came back with an agile headbutt, but the elephant proved too handy with those 7-foot tusks. Despite speed and agility, the rhino lost. Size and weight won the day. The bull elephant retains his heavyweight title.